Python external libraries. So as name suggests, and we are going to discuss some external libraries that do not come pre-installed with Python. Okay. The first library that we are going to discuss is NumPy, short for numerical Python. So the NumPy package provides tools for scientific and mathematical computations in Python. For example, NumPy includes functions that can be used to perform linear algebra operations, fast Fourier transforms, and statistics, etc. So NumPy must be downloaded and installed from this link first. Let me complete this slide, and then I would give a pause for you to go to this link and install NumPy on your computer. So first of all, it uses an array data type, which is similar to a list data structure in Python, but it is faster and more flexible. It contains elements of same type, can be created using array, which we will see shortly, array constructor from the NumPy package. So I will pause for a while. Meanwhile, you can go to this link and try installing it on your computer. Okay, so for example, if I go to numpy.org, install, let me wait a minute. Yeah. So here we have different forms in different ways we can install. So Conda is a package which manages many more packages together, but we will be using pip. So try running this on the terminal, pip install numpy. It might be possible that pip may not be installed on your computer. So try running this command, go to terminal or the command shell on Windows platform. So I'm running pip install numpy. So on my computer, it is already installed, so it says requirement already satisfied. Let's see what it says on your computer. All right, so first of all, you need to, if you do not have a pip stands for the Python installation package, and you need to have it installed in order to install some different external libraries. So pip, after installing pip, you can simply run pip install numpy to install the NumPy library. So we were talking about how do we create objects in NumPy. So we create an object with the help of array constructor. Array constructor means like the method that we can use to create one-dimensional or multi-dimensional arrays. So first of all, since NumPy is an external package or external library, we need to import NumPy. And here, so we have seen that how we can import the external libraries, external modules. Okay. But we are seeing it for the first time that we can give it a name as NP. We can give it a name as like CSE or whatever. So once we name it, we do not need to call that package, that imported package, by its original name. So here we are calling it import NumPy, importing NumPy, and giving it a name NP. So whenever we need to call any function or any method in that package, we can just call it by its alias. Okay, so NP, which will refer to NumPy, dot array dot notation is used to access any attribute or any method from that imported module, and then we can create an array by specifying the number of elements in the form of a list. Okay, so here importing NumPy package and name it as NP to use in the current module. As I said, accessing array method of NumPy package NP, and we are creating an array and assigning it to and giving it a name my underscore array 1, and then we are printing it. So it will create a simple one-dimensional array 15.5, 25.11, 19.11. It looks simple right now, but a little more complicated compared to just defining it in the form of a list. But you will see it is more powerful compared to list operations. So we can also create multi-dimensional array by specifying a list with a tuple for each dimension elements. So for example here, so first of all, just always remember that np.array, we have to specify everything within the braces, within these braces. What we are specifying? A list. Okay. Now this list contains 2 dimensions. Each dimension is a tuple. So first dimension is this one, and the second one is this. So this is first row, and this is second row. So 34, 25, and 16, and 12 in the second row. So when you execute this code, print my array 2, it will show you a 2-dimensional array. Similarly, you can create as many dimensions as you want. Okay, and we can also create a multi-dimensional array with the help of a nested list. So for example, we have a list, and we have already seen how we can create nested list within list. So here, assume that you have a list, nested list, and you want to convert it into a NumPy array. You just pass that nested list into np.array method, and it will create the same thing, a multi-dimensional array. Okay. And we are only covering it's just a brief introduction about these external libraries, just to help you how can you install any external library, how you can familiarize yourself with these kind of things, and you are more than welcome to explore yourself online. Okay. So the next thing, sometimes an array must be created before the element values are known, and changing the size of the array is an expensive computation. So NumPy provides functions that create empty precise array. So there is a zeros function, creates an array with a 0 for every element. Because what happens is, when you create an array, so for example, let's say 10 elements, and later on you realize that you need to add some more elements in it. So what will happen is, it will create a new array with the 11th element, or let's say you need to add 10 more elements. It will create a new array with the first 10 elements, and then add a new, let's say, new dimension of 10 more elements. Okay, so that is why it is important that you can create an empty array, or like array with the predefined values, predefined, let's say, zeros, or predefined all ones. Okay. So ones function creates an array with 1 for every element. Zeros function creates an array with the 0 of every element. Argument to zeros and ones, it could be an integer that defines the length for a one-dimensional array if it is only one integer specified. It could be a tuple, which is specify number of rows first, and the second parameter would be number of columns for a two-dimensional array. So let's see this. This is an example. So after going through these slides and modules, we will actually spend some time practicing with this. So here again, import NumPy as np. We are creating a zero array, and then you print, and then you can specify the two dimensions with the help of a tuple in it. Okay. Array operations. Some common operations that you can perform is to create a sequence of numbers like 0, 1, 2. So how do you create usually the sequence of numbers without knowing any NumPy package? If you have to create a sequence from 0 to 10, what function do you use?
Would it be like a list function?
List function? What list function? So you need to specify, let's say you need to generate a sequence from 0 to 100. What would you do? You would be creating a list containing 0, 1, 2, 3, and all the way until 100? Or what? Salah? Hmm? For loop, but what function would you be using?
Like for x and range.
Range is actually the function which actually generates the sequence of numbers. Okay, so like 0, 1, 2, 3, we can use a range function to generate the sequence of only integers. Okay, it only supports integers and not fractional values. So what if you need to generate a sequence of numbers with the fractional values? So here in the NumPy library, we have a linspace function where you need to specify start, where do you want to start from, where do you want to end, and there is an optional parameter which is not bold here, the number of points you want in a function. So when you use this, it creates a sequence by segmenting a given range within a specified number of points. So example, linspace has 0, 1, and 11. So it will generate a sequence of numbers between 0 and 1. Here 1 is inclusive. Okay, in range function, the end parameter is exclusive. Okay, if we specify, let's say 8, 0, comma 8, 8 will not be included. It will generate a sequence from 0 to 7. In linspace, it generates a function between 0 and the end parameter, which is inclusive, and it will create 11 points in between these two boundaries. So the sequence of elements between 0 and 1 generated. You can see 0, 0.1, 0.2, 0.3, and all the way until 1. Okay, so in order to generate an integer sequence, you can simply use the range function. In order to generate an fractional sequence, you can use np.linspace function. NumPy also supports generating a sequence of integer values, which is np.arange. Okay, so in this function, you need to specify the end index. This is the required parameter. Of course, you can also specify start, and you can also specify offset, as same as you would do in range function, and it can be used to generate sequence of integers. All right. Say mathematical operations. So if you have to perform some mathematical operation, unlike list, in which plus operators actually concatenate list. So when you have to list L1, 1, 2, 3, L4, 4, 5, 6. So print L1 plus L2 would give you the result 1, 2, 3, 4, 5, 6. It concatenates to list. Again, this is important from your exam point of view. You need to look at what function or what operation is being performed. If you are executing a plus operation between a simple list L1 and L2, those two lists will be concatenated together. But if you are performing the same function on NumPy's arrays, it will actually perform the addition operation between these two lists. So we have A1 as a NumPy array, A2 is also an array. So when you add both two together, it will add 1 and 4, 2 and 5, and 3 and 6. So you will get this result 5, 7, and 9. Okay, so when you see some kind of question like this in your exam, first of all, look at whether an object like A1 or L1 is a simple list or a NumPy array. Okay, if it is a simple list, just concatenate together. If it is a NumPy array, then perform the real addition between the positional arguments 4, 1, and 2, and 5. The third argument is added with the third argument in another list. Okay, understand? Great. So all right, so let's try practicing with this. So suppose we have array 1, np.array 10, 20, 30, 40, and np array 1, 2, 3, 4. So let's try practicing, or maybe I can pull up the demo.